Okay, hello again, grade 10. So now we're going to look at diffraction. So this means the sharpness of bending. So in other words, how do waves behave around obstacles and openings? How do they change in shape and direction? So have you guys ever been down to the coast? Most of you have been down to the coast. There's a lot of rock pools by the beach. And I'm sure you've noticed that as the wave approaches the rock pool, okay, it might be looking straight. So then it hits that opening, the small little opening for the rock pool, and then it changes direction. All of a sudden it becomes circular in shape. It's no longer straight and it's bending. It's because water is liquid, okay? Water can move through can fit the shape of a container and can move through different spaces and holes, and the water wave or the ocean wave shows us beautifully as how we have these straight wave fronts, and then all of a sudden they hit this obstacle or this opening and they change their entire shape. Okay, another example of this is perhaps you would see in a sunrise or when the sun is breaking through clouds. The clouds are the obstacles, and there are little pockets of spaces or holes in between those clouds, and the sun is coming through. So the sun is the light, the sun is the wave, or the light is the wave, and it hits the cloud, and therefore it is moving through those different holes and therefore changing its direction and shape sometimes, not all the times with light waves. You don't always see it all the time because of the frequencies. But here is a beautiful example of what you will see with the water wave and even with a light wave. It's moving through that small opening and it is changing direction. So this is a nice way of actually putting it all together. But we're going to go through the definition now in more detail, and then hopefully you guys will feel more comfy. So grade 10s, make sure you fill this definition in on page 13. It's the diffraction is the bending of waves around an obstacle. And then go to the bottom of page 14 where you've got your two pictures. One is a schematic and one is an actual representation of a rock pool. And I'm going to go through how you can see diffraction in three different waves. Okay, so in water waves, think about just like I said with the rock pool, but think about the waves entering a harbor. The waves will bend around small boats and disturb the water around it. However, the smaller the wavelength, the lower the diffraction. So please write this down, underline it, do something. The smaller the wavelength, the lower the diffraction. Okay, so if that wavelength is not big enough or have a significant distance, it is not going to disrupt the bigger boats. Okay, so it is not going to bend or change or move around the obstacle because of the wavelength is just not long enough. Okay. For sound, waves are diffracted around corners or from other rooms. So examples of how sound diffraction works is if you look at forest birds or owls, for example, they communicate using long wavelengths to communicate because they know that or evolution has given them that advantage that their sound is going to be diffracted amongst the trees or amongst any sort of obstacles. Light, as I said before, diffraction is observed of light waves, but only when the waves encounter obstacles with extremely small wavelengths, okay? Such as that the particles are suspended in the atmosphere. Why is that? Because light has got small wavelengths, but high frequency, okay? We're going to get to that with EM spectrum, but I want you guys to write this in a piece of paper, write this down on your page, whatever's going to help you remember this. Just remember that the diffraction is going to increase with wavelength, and obviously decrease if the wavelength is very small. So those of you that do geography will really appreciate this picture, but this is actually really, really nice to put all three that we've looked at in context. So we have land over here, and then we have these little coves and these little nooks and these little crannies, and we have waves approaching this land. This land is not straight and beautiful and uniform. There are different shapes. And can you see how this can be considered a barrier or a boundary or a surface? And the shape of that surface is impacting how the wave is going to behave. So let's look at this reflection example here. The wave enters, it refracts a bit because there's some bending, because it is moving from deep to shallow. Then as it refracts, it's hitting the shoreline and it is reflected back to the medium. It's reflected back to the medium at a different angle. Okay, so reflection sends that energy back. Let's look at this over here. Here, once again, the first thing that's happening before anything else is refraction. The waves are refracted, okay, in the shallow water. But can you see that this here is our little space, our little hole, okay, a little opening to the cove. And now it is changing complete shape and direction. It is becoming more circular in nature. Okay, so it allows the energy to squeeze through the strait. On this over here, they call this a headland, okay? The waves approach, there's diffraction, and it's diffraction towards this headland. So refraction focuses energy on all the sides of this piece of land over here. And once again, just over here, this is a beautiful picture of how this refraction happens in the cove, and it diffuses the energy, it disperses it. So guys, take a picture of this, print it out, stick it in your book. What you do with these little lessons, or how you put these concepts together in your head, is going to impact how you are going to do in the exam, because we like application questions. We don't just like adding theory all the time. Okay, so make sure that you have got everything covered in. So page 13 and 14 should be completely complete at this stage of the game. Okay, the next thing I'm going to do is I'm just going to go through superposition so that next week you've got an idea of what's coming with interference, wave interference. Okay, grade 10. So what we're going to do now is we're just going to look at superposition. So please make sure you fill in that definition on page 13. This is when waves meet, overlap, or interact. So in this image over here, we have got two different types of interference. And this superposition impacts interference. So you've got two here. You've got constructive. Let me just get my highlighter. You've got constructive and you've got destructive. So this will be covered in more detail next week. Mr. Ginsberg's going to teach you this, but I'm just going to give you an introduction of what to expect. Here in this column, let's just split this down the middle. In this column, you have two waves of equal amplitude approaching each other. I want you to think that both these waves, which are two crests that are approaching each other, have an amplitude of about 2 meters. When they interact or superimpose over here, okay, what is the amplitude going to equal to? It's going to equal to 4 meters because it's the sum of the two crests coming together at that moment in time. Then what happens is those particular waves or those crests are just going to carry on this. They're just going to return back to where they came from. They're going to carry on, so they interact and they carry on moving. For destructive interference, what happens is you have a crest and a trough. They are approaching each other. Okay, now if they are of equal amplitude, so you have a crest of 2 meters and you have a trough of 2 meters, they are going to, when they interact, they're going to cancel each other out. That's what's going to happen. Okay, and then once again, they're just going to carry on moving. So this here represents the canceling out in destructive interference. I don't want to go into any more detail about this because Mr. Ginsberg's going to teach you next week. So just please fill in your definition, and then on next week you guys will be doing page 15 and 16. You guys will also be doing the test your knowledge part of the booklet. So I need you guys to finish exercise 2. Make sure that you've completed everything. If you have any questions, if you're confused in any way, please just drop me a message and we can chat. So stay safe. I hope everyone is in good spirits, and we will chat next week.